Today's contents of the webinar, we're going to look at the introduction to gas system design. It's a very general overview of gas systems and the design considerations. We're going to take a quick tour of the MagiCAD piping module itself. Then we're going to look at the gas design workflow using MagiCAD for Revit. I will then give a demonstration of performing gas calculations with MagiCAD in Revit. Then there'll be a short summary at the end. The introduction to the gas system design, I'm just going to look at a general overview really of considerations for gas system design and calculation. The entire gas system is a complex system itself and requires conformity and alignment with local regulations. This in terms of performance and safety. These aren't so much what we're going to consider today. We're going to look more at the piping system design and calculation elements of it. That's the main focus of what the calculations are for, and they will include the flow rate and pressure drops across the system as required. The gases we're going to look at today is natural gas, but gases can be anything between natural gas and propane, and you can add all these as you see fit into MagiCAD calculations, but you do need to be careful and make sure you put the right properties into the settings for that. Most gas design involves converting the duty of the loads to a flow rate by virtue of a calorific value, which basically determines how much gas is burnt to produce a certain heat output at any device. That's the underpinning factor in the calculations itself. Sometimes there's a diversity required. Not all gas devices will be at peak duty simultaneously. This could be when you've got apartment blocks that have, say, hot water from gas-fired equipment, and not everyone will be having a bath or a shower at the same time, so obviously the gas load will be diversified. Also within, for example, gas taps in school science labs and things like that, where not every gas tap will be on constantly all the time. Pipe sizing itself, another consideration is that it's an iterative calculation. That's how MagiCAD does it. It iterates and produces the end result. It checks each pipe route to make sure that the pressure drop is within range or within criteria, and then moves on to the next one, and that's how the pressure for the whole system is calculated, and the subsequent pipe size is calculated as well. Just going to have a quick tour of the MagiCAD piping module before we get started into the gas calculations. The module supports and includes gas, heating and cooling, domestic water services and drainage systems. It also includes sprinklers, but this is an actual add-on calculation module to the standard piping package. And then we're going to look now at the toolbar for the piping module as well. In the piping module, you'll see we have some general tools, and then we have the piping modelling tools here, so modelling and coordination to help speed up your modelling of all your pipe services. Then we can add pipe to the model using the standard 2D or 3D pipe drawing. We can add and create content for different pipe materials here. We can also add products for piping services, outlets and equipment, devices, etc. Then we have our calculations. There's the controls for things like nodes and diversity. And here's the calculations themselves, the heating, cooling, domestic water, drainage, and gas sizing and sprinkler as a separate package to the pipes services module. Then we have some specific piping connection tools for pipe services, drainage, sprinkler, etc. as well. We're just going to go over the main points of the gas design workflow using MagiCAD for Revit. So the workflow is, broadly speaking, designed and calculated like this. You can establish early estimated loads for equipment and devices, but instead of modelling all those, you can actually add these to the gas network, the gas pipes, using MagiCAD connection nodes, and you can just add your estimated loads on for the branches of the pipes rather than having to model all the individual pieces of equipment at early stage. Then you can run prelim gas sizing and pressure calculations. This will inform you of your sort of early stage gas sizing and pressure requirements. You can make any adjustments and coordination, etc. accordingly. Then if we move into detailed design, then we can start adding accurate equipment, the duties, the pressure requirements, and all the pipework ancillaries such as valves or gas meters, etc. And they can also have the gas pressure drops, etc. assigned to them as well. Then you would rerun all the sizing and pressure calculations at this detailed design stage with all the ancillaries on, all the final loads and duties calculated. And then when you rerun that, that is your final detailed design calculation completed. Now let's look at a demonstration of performing these gas calculations within MagiCAD. There's a certain number of key steps in the process of using MagiCAD and gas calculations. These are at least define the gas types and the properties of these gas types in the project. This could be calorific value and density and viscosity and things like that. Then you need to define diversity if it is going to be based on number of devices required as well. That will be a rule you've got to set up as well. Then you create the gas piping network, adding the devices, equipment, or nodes if you're doing that instead, along with the gas flow rates and inlet pressures as required. Then you can run the gas sizing and pressure calculations, making sure that you put the correct values into the dialog box based on the system pressures, etc. And then finally, once it's run, you can review the results in the report and then update the model if you're satisfied with the results. The first thing we're going to do is set the standard. At the moment, we have released gas calculations is our first release, and it's based on the UK standard of CIBSE. There are other standards coming in the near future for other market areas as well. But for the moment, this is just the calculation standard we're going to be using today in this demonstration. Following that, we can start to look at actually creating our gas pipe network, which we're going to base our design on. This is an early stage example. We need to go into the data set and firstly configure these gas types. Here you can see I've added one myself already called natural gas. I've just used some values that are typical in the market here in the UK where I'm based, but you'll have to obviously adjust these values to your own markets as required. I've also set up some diversity tables as well. So if you, for example, have a number of devices, as that increases, you can diversify your gas peak flow rate. Then of course you can set that up with some diversification rules there as well. You don't have to use that every time. It's just something you can configure in the data set prior to using it in the project. So once that's done, going back into the Revit project here, you can see that I've already configured a pipe network. The pipe network, you can see where the open end is there. It comes in like that's the gas inlet section of the pipework, and the network runs out to serve various pieces of equipment such as boilers, water heater. I've got a future phase, so I've got a future extension of this building. I want to make allowances for that as well in this calculation. And then I've got some high-level heaters that eventually will be going into this space as well. So all I've done, I've gone into that calculation connection node previously and added these nodes on. And when you add them, you have to give it some information so it knows what to actually allow in these nodes. And I've put a description so I know exactly what it is that I'm representing in these nodes, so water heaters or boilers or whatever it is. I also add my estimated loads as well. You can see there 20 kilowatts. That's my estimated peak load to my heaters. And there's my inlet pressure as well. So I've put 2.1 kPa as my desired inlet pressure on there. And that makes a big difference to the calculation because you've got an inlet pressure on the device, and then you've got a pressure coming into the system from the gas mains, and that is where the gas pressure is calculated and the pipe size accordingly. You can see I've tagged these pipes as well with the sizes, so got an indication of that. I've modelled it all there at 100, you can see, or mostly at 100. That will change as the calculation is performed, obviously, as it can recalculate the gas pipes to meet the pressure requirements. If I wanted to, I could also add diversity as well now. I'm not going to do this in this example, but this is where I could do this. I could add it manually like that and just put a figure of diversity in. I'm just going to run the gas calculation now. Here it goes. I choose my gas type. There's only one, it's natural gas. If I wanted to, below that, I could choose my diversity. I'm not going to in this example, but that's where you would do it. And then below that, you just see I've got a gas feed point pressure, which I can now add or configure. So that's my confirmed pressure off my gas utility supplier, for example. And then I can set a warning as well, just below that, as to what my maximum pressure should be from inlet of the gas system to the inlet of the device downstream of the pipework. So I can put a value in there as well, and that'll just flag up a warning for me in the report if there's a problem or if it needs to flag anything up along those lines. And then once I'm happy with all the figures, I can just press OK and then just select the pipework, and then it will now go and produce the calculation report. So I can come in here and preview what's going to happen in the actual project to the pipework and device, etc. before I hit update. So I can see there's all my power outputs. If I just zoom to that, you can see there's that connection node with that load on there. So that's what's happening. That's why it's indicated like that in the report. And you can see it's actually converting the kilowatts to an actual flow rate based on the calorific value, etc. And then it's using that value to then inform us of velocity and pressure drop per meter and things like that. And I can see my total system pressure there as well through that system, and there's my index run as well. I can see that. So finally, I can look at my pipe sizes. Here's my old sizes and here's my new calculated sizes. That all looks good to me, so I'll just hit update. And then now it updates the model to reflect that. And you can see now my pipe sizing has changed from that 100 diameter. My inlet is now 50, and it's changed the size of the pipe work around the network as well. It's also populated the flow rates on the connection nodes as well, those converted flow rates. So I've got a good idea about that as well, which is great. Now we're going to move on to the detail design stage of gas calculation, and you can see the fundamental difference now is the fact that instead of having connection nodes representing all this equipment, we've actually installed all this equipment. And whether it's the gas-fired water heater, the boilers, the valves, or the gas-fired heaters above, they all need a gas duty in kilowatts and a required inlet pressure on each of these, so we can calculate the pressure drop from the start of the system to each of the pieces of equipment, so we can complete the pipe sizing correctly. You can see that I've also tagged the pipes with some more detail calculation tags, so I can see what's happening in the flows, etc. And the way to install these products is using our gas device or gas valve categories, and then we just add those components in. You can assign a pressure drop to them as well, which is taken into account in the calculation. Here's just an example of some gas-fired radiant tube heater that you can add as many gas device types as you want into the project, and they behave in a similar kind of way when you install them. That's just a few examples of what we've got. We've got a lot more in terms of content on our MagiCAD cloud. Just a very minor selection of a few examples. But yeah, once we've installed these and the system is connected up, ready to roll, then we can run the calculation. So if we go to the calculation, back down to the gas sizing and pressure drop, and here's the dialog box that was there previously in the early stage design. I'm not going to change anything in here. It's all the same conditions as I want it. Just now I've got this updated equipment in here. So I'll just select the network pipe, and you can see there's the results. It looks very familiar to the previous one, of course, but now it's got all the different items of equipment and if you want to have a look at those, you can just jump to it from the report straight into the model as shown there, and you can see the outputs and the pressure properties at each of those devices as you go. In the report as well, you'll notice that there's the flow rate and velocity and the sizes are all calculated. There's the old and new sizes, so you can see it reducing again. And if you just go to update the model now, you will see that it will now resize all the pipework as it should do. Incidentally, I didn't continue the early stage design into this one, otherwise it would have been very, very similar to the pipework, but I wanted to show you the overall tool working with a beginning pipe size of like 100 mil or whatever it was, so you can see it all reducing. And you can see as well what it did to the valves. It also reduced the valves or resized the valves to the new size as well, rather than just putting reducers on it, which is great. And you can see all those pipe work tags populated, so you can see all the detail of all the flow rates and the diameters and pressure drop per meter, etc., through that pipe work section. If you want to add diversity to the calculation, as an example here, I can just add 80% diversity for, just in theory, and for whatever reason I wanted to these gas-fired warm air heaters. So I can just choose the pipe work that's going to be 80%, or the branch 80% diversity. And now when I rerun the calculation, you will see that the flows will be diversified by that amount. You can see it says 80% in the report on diversity, and that will reflect into the actual flow rates, and hence the pipe sizes serving those units as well. So you'll see when we go to update the model from this calculation report, the new diversified flow rate will be used, and you'll see that populate in those pipe tags, which you'll be able to see in a few seconds now. So now you can see it's gone to this new value in there. So that's my new diversified pipe system connected up, ready to go. Okay then, so a quick summary of everything we've gone through. So MagiCAD, as you can see, can perform detailed and accurate gas sizing and pressure calculations within Revit. I think you've seen examples of that through the stages as well. The tools will allow early stage detail design and a range of equipment and devices with gas flow properties to be configured. So it's fully able to meet your requirements with pretty much any gas device that you can have in the system, and it will calculate accordingly. And the output of this, apart from the model being updated, is also you have a full set of calculation results and reports which are created for you to check and review, and then also can be stored as a record of your calculations as well.